example. All right, so we have hydrogen and iodine making hydrogen iodide. It's not an acid because it's a gas here. And so I'm going to go ahead and, even though that's written there, I'm going to go ahead and write it here. And so we've got hydrogen and iodine making some hydrogen, 2 hydrogen iodides. All right, it says equal moles of H2 and I2 vapor are mixed in a closed container and are heated to 700 degrees. The initial partial pressure, the beginning pressure, and we only put H2 and I2 in a container, so there was no HI in the beginning, of the 2 gases is 0.5. So each one has a partial pressure of 0.5. And we can put atmospheres in here because we can be dealing with Kp, because they're asking me to find the Kp. So this is 0.5 atmospheres, and this is 0.5 atmospheres initial partial pressure. And in the beginning it says we just put those 2 gases, so this guy wasn't mentioned, and many times if it doesn't mention it, that's going to start out as 0. Okay, all right, so I'm going to give you a little hint for as you start doing a RICE problem. Anytime if you know the K, if you know the constant, you'll have X's in your RICE table. If you don't know the K, you should not be putting X's in your RICE table. I am looking for the K in this problem. See here, what is the K for this reaction? Okay, so because I don't know that, I'm not going to have X's. I have a lot of times students will put X's in their table and they don't know what to set it equal to. So if you're looking for K, you shouldn't have X's. So they must have given us some sort of hint about how much has changed. And it says that 35% of I2 has been consumed when the reaction gets to equilibrium. 35% of I2, so 35% of this amount of I2 has disappeared. Okay, not totally disappeared, it actually reacted and become HI. We know the law of conservation of mass. But basically we know that this has lost some, and it lost 35%. Now, 35% of this value, and sometimes students don't know how to do percentages, and I just think that's kind of an important thing to do. Even if you wanted to know if something's 35% off at Target, I think you should be able to figure out how much 35% off, how much you should be saving, because you shouldn't just go up and trust the, you go trust the checkout. They may just give you 10% off. So I feel like you kind of should know, and some of you are like, oh, there's an app for that. You shouldn't be able to figure out percentages. So to figure out 35% of this initial number, I'm just going to take that initial number and I'm going to multiply this not by 35, but I'm going to multiply by 0.35, which is the decimal. Okay, and when I multiply 0.5 times 0.35, I get a 0.175. So I know that this is losing 0.175 atmospheres. How did I know that? Because it says that 35% of it has been consumed. Now some students go, can I figure out what 65% and that's how much would be left? Sure you can. That would get you this number right here. So either way, so that's going to get you, if I now subtract 0.5 minus 0.375, I'm going to get 0.325 atmospheres. All right, hopefully you're with me. All right, up a while ago we were talking about the C. C is where the coefficients matter. Coefficients matter. And for every iodine, there's going to be the equal amount of I2 that's going to react. So if 0.175 of it reacted, it had to have reacted with 0.175 of the hydrogen because it's a 1-to-1 ratio. Do you see that? 1-to-1 ratio. So, and if this is a reactant and it was losing, this reactant also has to be losing. You can't be losing one reactant and gaining one reactant. So if I'm losing it, that means I'm going to be making product on this side. So I'm losing reactants, and so this is what we call a forward reaction. A forward reaction means it's making product. A forward reaction is making product. A reverse reaction reaction is making reactants. All right, so if I take 0.5 minus 0.175, I get 0.325. They're not always the same numbers, it's just they start out the same there. Okay, if it's a 1-to-1 ratio, this number should always be the same because C is where the coefficient comes into play. All right, here's where students usually make the mistake. Now, for every one iodine, there are actually twice as many HIs. For every one I2, there's twice. So this number here is not going to be 0.175. It's going to be twice that amount because it's a 1-to-2 ratio. It's stoichiometry. So this is actually going to be 0.35 atmospheres because for every one, there are 2. So I doubled that number right there. This is where that, in the change, is where the coefficients should be proportional. So we get 0.350 atmospheres. Okay. So now that you got your numbers, I've got all my numbers at E, that's the goal to get to E, I can now calculate K. K is the products over the reactants raised to their coefficient power. Everybody was gases, so we didn't have to worry about any solids. So we've got this guy squared divided by 0.325 raised to the first and 0.325 raised to the first, which you could have done 0.35 squared. And you should be getting, according to my answer I got up there, 1.16 is our K. All right, that one wasn't too bad. This one taught you 2 things, how to deal with percentages, and it taught you how to deal with the proportion. So that was and to initially set up a Rice table.